Dr. Fox is a senior fellow and the acting director of the research program at the East-West Center, USA. He conducts research on land use and land cover changes in Asia and the impact of these changes on the region and the global environment. Today, Dr. Fox is talking on 25 years of forest dynamics in Nepal. Dr. Fox, please proceed further.
Well, this is a project that was funded by NASA Land Use and Cover Change Program. It is very interdisciplinary. Myself and Samit Saxena from the East-West Center did a lot of the social science, and Samit did the social science number crunching. Casper, Jamin, and Alex are the remote sensors behind this. And then we had very strong Nepali counterparts, Ram Chantry and Pitambar Sharma from Resources Himalaya, and Naya Sharma Podel, who I can thank for getting me into this session today, from Forest Action Nepal. Let's see. So between 1950 and 1980, forest cover decreased by about 50% across the country. In 88, the Department of Forests had identified 61% of the nation's forests that could be transferred to local communities. Today, community forests cover 20%, 23% of the country's total forest area, and there are some 18,000 or 19,000 user groups. Nepal is famous globally for its community forest program, but out-migration from rural areas in Nepal is also frequently cited as a driver of socio-economic change. Today, or before COVID, there were about 4 million migrants. I've not had a chance to figure out what that stands today. And 32% of the nation's GDP was drawn from remittances. Okay, so numerous scholars, the literature on Nepal's community forestry is so dense, I can't begin to describe it. They claim that forest transition occurred in Nepal because of community forestry and migration. But this change was not mapped because of the difficulty of mapping in mountainous environments. And then I want to make a point here that henceforth I'm going to be speaking of tree cover, because our image analysis does not separate trees grown in fallow fields from tree and private lands from trees growing on plantations in forest. So just a couple slides. By the way, I was Peace Corps in Nepal 50 years ago. I'm an old man. I used to drive this road. I'll tell you, 50 years ago, this was a very degraded forest. And in Nepal, I think it's important to understand that the real story was not deforestation, but degradation. So once you took the pressure off the land, it had the chance to, most in the forests in Nepal are regenerated, not planted. But because of migration, we're getting a lot of people abandoning rain-fed agricultural lands. Here's an example. I suspect these are planted trees for poles because they look similar. And you're also in some places, particularly where international organizations were involved, you've got plantations. So we had two objectives. One, to build a comprehensive database of changes in tree cover since 1990 using remote sensing, and doing it what was at then the smallest administrative unit, the Village Development Committee. And then to integrate that with social biophysical data in a spatial format. So in 2011, here are the 4,700 VDCs across the country. In 2015, they changed the constitution, and these have been reduced down to 460 rural municipalities and about 200 some municipalities, which means that this kind of time series analysis will not be able to be done again because we use census data at the VDC level to do this. So let's just look at the remote sensing. Well, here's Casper Herney. wanted to point out that Nepal, when we talk about it in 3 biophysical zones. The Terai down south next to India is an extension of the Gangetic Plains. The Middle Hills and it was dominated by malaria until the 60s, so few people lived there. The Middle Hills is where most people used to live, and then the high Himalayas outlined in red. Gorkha zone stretches up to the Tibet border, so you get a little bit of mixture of Middle Hills and mountains there. So how did we do this? Well, first of all, Casper spent a lot of time doing topographic image correction, and there's a paper out on that. Then, of course, we had dense stacks of images for each year, and we were able to look at cloud and cover and take the best images or the best parts of each image and create a single image that minimized clouds, haze, and shadows. We looked at, this is actually the road up to the village I lived in 1972, and look at changes in tree cover through time. And you'll see up in the upper right how they put together a fitted line to be able to model it. Then we had training data collection from this across this area. And then with the model and the training data, we were able to put together a composite image of tree cover for every single year between 90 and 2016. Easy Mode had done its own one point in time analysis. So we had a 1990 and a 2010, and we compared our results with their results. And then we did our image classification using random forest classifiers, and we ended up with an 87% forest user accuracy. So that was the remote sensing, and we think we've got the best remote sensing land cover of Nepal that's available, particularly through time. Now, let me just briefly or very quickly run you through what it looked, how it changed through time. So here is that image again of the VDCs, and the yellow ones are the ones with the most increase in tree cover. The blacks, well, some of them are above tree line up in the Himalayas, some of them are cities down at the Terai, but most of the increase in tree cover was in the Middle Hills. And that shows here where we're going to see in the mountains, there's a 10% increase, the Middle Hills a 24% increase, and the Terai a 17% increase. Now we wanted to combine that data with social, economic, and biophysical and spatial data. So we created boundary files of all the districts and VDCs that existed in around 2016. We collected data on physiographical variables such as elevation, slope, aspect, and social type. We obtained the 2001 and 2011 census from at the VDC scale from the Central Bureau of Statistics. Unfortunately, it was not in a digital format. We had to hire a huge number of Nepali students to translate it all into a digital format. And then we conducted random forest multi-level regression analysis to relate these factors to tree cover change. So this, in a way, summarizes our results. The ones in orange are the biophysical, the ones in yellow are the socioeconomic, the ones in green are the spatial. You'll see the factor that had the most impact in terms of random forest relative influence is terrain ruggedness. When we use multi-level regression, we see that it has a positive effect. The more rugged the terrain, the more trees you have. The next variable in terms of relative influence was elevation, which is negative. The higher you go, so you're getting up above tree line, the fewer trees you have. Then, well, we should have known it, but we weren't looking for it, population density. The more people, the less forest. Makes perfectly good sense. Road density. The more roads, less forest. Northness here, again, the biophysical ones we cannot control. Actually, the spatial ones we really can't control either. But more road density and the more road, less forest, the more north-facing slopes had more tree cover than east, south, and west-facing slopes. Accessibility defined in the distance from the district center. Increased tree cover the further you were away from the district center. But here now we're really getting to the questions that we were looking at. What's more important, community forestry or migration? Well, in that period, 2001 to 2011, community forest user groups clearly outranked the importance of households with migrants. There are other modern households and owning motorbikes. Well, modern households, of course, means you probably have income from remittances. And owning microbikes, motorcycles means you have income, but it also, they're tearing up the landscape. So we had some good insights now. And because we did our own remote sensing at a national, well, let me do the partial dependence plots first. Just two things. Here's the community forestry group. Households that are members of community forestry, and up to the point where every household in the village, 100% belong to at least one community forestry group. We got total increase, almost a linear increase in tree cover. Migration, somewhere around 60, well, it goes down in the beginning, then it goes back up. Around 60% of the people migrating, or 75%, you get some increase in tree cover. So between 92 and 2016, we found a 26% increase in tree cover. We showed that it is positively associated with both community forestry and migration, but that community forestry was more important than migration, and was the most important socioeconomic variable outside of population density. Now, these results are very different than another study that used the Hansen global data set as their remote sensing data. And we're just writing that up right now. But my conclusion is that if you're working at the national level and you're using census data as one of your variables, that the Hansen data set in Nepal does not work. Whereas we were getting 26, we're getting something like 26% tree cover, 26 to 45, no. A doubling of tree cover almost. Hansen shows almost, actually shows a little bit of loss of tree cover. So that's just not the way to go. So we have produced products, and I think I'm probably going to run out of time. And here is our main Nepali collaborator, Dr. Ram Chetri, retired professor of anthropology, did his PhD here at the University of Hawaii. Thank you very much.
Very good. Thank you, Dr. Fox. So we have a few minutes for Dr. Fox. If you have any questions, please type or in chat window or Q&A. So here is a good quick question from Rajesh. I assume the data, both census and the tree cover, are not publicly available yet. Is there any way we can request those data for research use?
The tree cover data are available. And Rajesh, you probably can get my email off the back of the material provided. Email me and I will send you the access to the tree cover. The social science, well, the census data is available too. Yes, both of them are available. They're online, actually through a system run by the University of Hawaii. It's available. That data is available.
So Dr. Fox, so since the government of Nepal also conducted the nationwide survey, right, in a couple of years ago, maybe 4 or 5 years ago. So maybe I missed it. Maybe you have covered it. So have you compared with your numbers with that national study from the government of Nepal?
Yes, that was a good study. I think it was done by the Norwegians.
Yep.
Somebody up there. We both came, the main difference between them and us is that we did it every single year between 90 and 2016, whereas that was a one point in time study. But our end result in 2016 was about the same, about 40% of the country, an increase of 40. Well, I forget exactly what it was. It's somewhere around 40%, but I don't remember. It's an increase or a total cover. I think it's a total cover of 40%. Yeah.
Great. Thank you. Any other questions for Dr. Fox? We still have a couple of minutes. There is a question from Kangi. What is the difference between your map and Hansen's?
I'm writing that paper right now. As I said, Hansen actually shows a decline in tree cover. The paper that used the Hansen data set and the same census data that we use, 2001 to 2011, comes to the conclusion that flat areas, i.e. the tri and the low-lying areas that are irrigated in the hills, are the place that had the most tree covering, increase in tree cover. I think that's absolutely, totally, positively wrong. And using that data set was not appropriate here. Some of our public, I'm looking at the questions. We just had an article published in the Journal of Peasant Studies that looks at 4 villages and 2 districts northeast of Kathmandu, where Ram had done the Nepal. The Australian Nepal Forestry Project was the biggest forestry and most successful foreign-funded forestry project in the country. He worked with them in the late 80s and early 90s and did a survey back then. We compared his survey then with a new survey we did now, combined it with our remote sensing data, and came up with a bunch of interesting results. The remote sensing methods papers to both the topographic and how we did the remote sensing have already been published. An actual results paper on the remote sensing we're still working on.